everyone. In this video, I'm going to introduce powers. Powers or exponents were invented centuries back by early mathematicians. In the 16th century, Robert Ricorder named the exponents using these big terms, like the square if a number was raised to the second power, and the cube if the number was raised to the third power. And then we say a number, if it is raised to the fourth power, we can write it as a to the power 4. Now, during those days, they will say Zenzig. Then they know that the number is raised to the power 4. So all this was not known during that time. All what they knew were these terms. But however, in 1544, another mathematician named Michael Stiefel introduced the word power. So from the time of Michael Stiefel, there were no longer the use of these big terms. Instead, power was used. If a number was raised, it was raised to a power, not to any of these terms. Okay, so let's focus on the word exponent. This word exponent was formed from the two Latin words expo and ponere. So it was exponere, which was later refined to form the word exponent. Right. Now we go on to the word power. Power is a number being multiplied by itself a specific number of times. So for example, if we say 2 to the power 5, this 2 to the power 5 is the power. And then the exponent is the number to which a number is raised, which means only this number 5 is known as the exponent. But 2 to the power 5 itself is known as the power. Right, exponent represents a repeated multiplication, making numbers grow quickly. An exponent tells how many times a number can be multiplied by itself. For example, 2 to the 5th power means multiplying 2 5 times. This is different from multiplication, which is simply a repeated addition. For example, if we say 2 to the power 5, it means 2 times 2 times 2 times 2 times 2. Whereas 2 to the power 2 in multiplication, 2 to the power 5 will be just 2 times 5. So answers to exponents grow faster than the multiplication. Powers help us to write in short if a number is to be multiplied by itself many times. For example, 3 times 3 times 3 times 3 times 3, you have to count the number of 3s. 1, 2, 3, 4, 5. Then you will be able to tell that 3 is raised to the power 5. Here, the same thing applies. You have to count the number of 2s for you to be able to tell the power to which it is raised. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you know that 2 is raised to the power of 12. In the same manner, 3 to the power 8 can be written in a long expression like 3, you have to go counting 2, 3, 4, 5, 6, 7, 8. Right, 8 to the power 8. 3 to the power 8 is written like this, and 5 to the power 4 can also be written as 5, 1 times 2, 3, 4, 5. So this is 5 to the power 4. 1, 2, 3, 4. So this one will not be there. Okay. Right. Let's label parts of a power. Parts of a power. Right. If a number x is multiplied by itself n times, then it is represented as x to the power n. X to the power n is the power, where x is the base and n is the exponent. In this power, 2x to the power 3. So 2x to the power 3 is known as the power. And then 2 is known as the coefficient, and x is the base, and 3 is the exponent. So these parts of the power of a power have to be remembered. Right. You can meet a problem like this, 5a to the power 7, and they may want you to label parts of this power. So first of all, this whole thing is the power, and then a, this a here will be the base, and then 7, this 7 at the top here will be the exponent, and then the 5 will be the coefficient. So for today, that's all about powers. Meet you in the next video. Thank you.